Hello and welcome to the webinar New Generation Bio-based Technologies in Leather Making, brought to you by ILM and in association with raw materials pricing website, the Sour Report. My name is Isabella Griffiths. I'm the editor of leading leather industry business information brand International Leather Maker, ILM. I would like to acknowledge our webinar sponsor, Dutch chemical specialist Stahl. Michael Costello, Director of Sustainability at Stahl, will be one of the presenters today. As the title suggests, today's webinar will examine the new generation of bio-based chemicals that are applied in leather making, looking at sustainable sources of bio-based chemicals, as well as the financial and environmental benefits of switching to bio-based materials. Our two presenters will cover different parts of the industry and offer the perspective of the chemical supplier, Stahl, as well as the tanner's experience, Henan Prosper Group, of using bio-based chemicals in the tanning process. Before I hand over today's webinar to our speakers, I would like to give a brief introduction to International Leather Maker and the Sour Report. ILM was established in 2013 to fill a gap in the market for a media business that served the leather industry across several new media platforms as well as print. ILM covers the global leather supply chain and is also published twice a year in Mandarin. The website, internationalleathermaker.com, is updated several times daily with the latest industry news, views, and information. The Sour Report was founded in 1985 and is an online raw materials pricing, analysis, and trends website, which is updated daily from a network of sources from around the world for its paid subscribers. It is a useful source of market information for the whole leather supply chain, including traders, tanners, brands, and retailers, and associated suppliers. Now I would like to introduce today's presenters. The first presentation will be made by Michael Costello, Director of Sustainability at Stahl, who will present biotechnology and leather, how the industry is transforming itself. Michael has been Stahl's Director of Sustainability since October 2015. In his position, he plays a vital role in integrating sustainability into Stahl's corporate strategy. He works closely with all departments within Stahl to ensure sustainable innovations and other related initiatives are on the daily agenda of his colleagues. The second presentation will be by Tom Zong, who is the Chief Technical Director for Henan Prosper Group and will provide a tanner's perspective on the use of bio-based chemicals in the leather making process. Tom will give a brief introduction on Henan Prosper Group and then discuss the different types of biochemicals the company currently uses in its production processes and why, as well as how they have impacted the group's efficiency and what the benefits in terms of sustainability and quality are. Tom has over 23 years of professional experience in the leather industry, having worked at Henan Prosper Group since 1997 and specifically with biochemicals for the past 6 years. I will now hand over the webinar to our first presenter, Michael Costello.
My name is Michael Costello, and I'm here to speak about a very important and future-thinking topic, biotechnology and leather, its relationship to the leather making industry, and indeed how the industry is transforming itself, because there's a lot going on and things are changing quite quickly. So that's what the presentation is about. I'll talk a little bit first about the chemical industry in general, not just leather chemicals, but in general, how that is with relation to greenhouse gases and what we call renewable carbon. I will explain that. And then give some examples of real biotechnology that's already being used in leather chemicals in the leather making process, just to show you that there's quite a few things going on, and these are just a couple of examples of those which are already being introduced and indeed commercial in the market. And finally, I'll make a little what-if proposal, which basically is looking a little bit further into the future as to how a tannery, a leather manufacturing process, could work if the inputs into that process and the manufacturing associated with that process was more oriented towards biotechnology and bio-based chemicals. So, the chemical industry in general emits 7% of total global greenhouse gases. In the slide here, it says anthropogenic emissions. That means coming from human activity. So that's quite a significant chunk already of global greenhouse gases. But this could rise as a percentage of the total to 15% by 2030. And indeed, it could even rise beyond that to 30% by the year 2050. And the reason for that is because the chemical industry has been lagging behind the energy sector when it comes to the decarbonizing technology and introduction and normalization of that technology. So because the energy sector is already decarbonizing and the energy sector is the largest contributor at the moment to greenhouse gases, then as a proportion, the chemical industry is going to be larger in the future unless things change, but things are changing. But just to look at the energy sector to give you a sense of how that is decarbonizing already, the traditional generators of energy are still the most popular. But as you can see, and especially in certain regions of the world, renewable energy is already quite normal in certain regions. You can source already from so-called green energy networks, coming from nuclear, hydro, biomass, solar, for example. So that is already underway. It's still a long way to go, but still there are advances already in electricity sourcing, but not so much in chemistry. So the equivalent in the chemical industry of decarbonization in the energy sector is what we call a transition to renewable carbon in the chemicals and plastics industries. The plastics industry really is part of the chemical industry as you're synthesizing products from the raw materials. So what does renewable carbon mean? Let's just keep it simple. What it actually means is anything that's not extracted or mined from the geosphere or from the earth, the crust of the earth, let's say. So anything above that that could be extracted from the air or from waste or from things that could be recycled or even from plant life, that is renewable carbon. But anything that is extracted from the earth is not. So there are three sources then of renewable carbon for the chemical industry. And the first one, and that's the one that we're focusing on here, is bio-based raw materials coming from biomass, so plants or agricultural waste, organic materials. Then if you can recycle anything that's already been made, that's also considered renewable carbon because you're not extracting anything from the earth. And last but not least, there's a lot of research going on here, although it's still quite futuristic, is to capture carbon dioxide from industrial processes, from the air or from the emissions that come from an industrial process like cement manufacture. That carbon dioxide can be captured and used in industries in different ways, indeed in the leather industry. But today we'll focus more on biomass because that's the one that's the more advanced version of renewable carbon. And of course, as expected, it is more expensive to use these, let's say, renewable resources than the typical traditional virgin petroleum resources, which are mostly used in the chemical industry right now. However, the more, let's say, renewable carbon resources that you use, those are the green boxes, then the more expensive the product becomes as a result of that. So if you look at the percentage of the bio content in the chemicals, the cost of those chemicals generally goes up with the higher percentage of bio content. Now that is changing. It will change with respect to economies of scale that are already up and underway, but still virgin petroleum still is the most efficient way to make chemicals and the cheapest way. And that is part of the reason why the chemical industry has been a bit slower to move on this, but things are changing. If we look schematically, the way that biomass can be converted into raw materials and chemicals, it looks here the same as crude oil and refined oil, but in fact the crude biomass doesn't come from the ground. Of course, that's the main difference here. The crude biomass could come from plants, agricultural waste, other areas where you're not taking it from the geosphere. So that's the big difference here between the two processes to get these materials made. And then when you go down through the chart on the right, you go to the refined biomass, which is then converted into bio-based chemicals. And this is done by biotech companies. Often fermentation is the process used, but it doesn't have to be. But these are the typical biotech companies that you hear about in the market. There's so many of them now. It's a big growing industry. And companies like us are working with these types of companies to provide us with bio-based raw materials, which could then be made into chemicals and leather chemicals. So that's roughly a schematic comparing the two processes of creating chemicals, either from the biomass route or from the traditional, let's say, petroleum crude oil route. Now, we have an example in leather chemistry of a technology that's called probiotics. And this is a technology that was introduced a few years ago. And I've used this example not simply to promote this particular product, more just to promote the idea that a new bio-based raw material that was introduced into the market relatively recently can actually be very successful in a short amount of time if it is presented and focused and designed in the right way. Because this particular one is based on natural raw materials and some probiotic cultures, which is the same probiotic cultures, by the way, that are used in yogurt, in food. It's the same idea. And then through a fermentation process, metabolites are produced. And those metabolites can be formulated then into real liquid products, which can be used in the beam house stage of the leather process. And what we have found, and this has been proven commercially over the last few years, is that synthetic surfactants that are typically used in this beam house leather process, because it's a cleaning process basically, and even some bactericides which are used to prevent bacterial growth, can actually be replaced by these probiotic metabolites. What difference does that make? Well, obviously you're taking out something synthetic and you're adding something that's naturally produced, which has an impact on climate change. But even in the actual leather process, the water waste that is produced during the beam house process, which is significant always, that is much reduced in its chemical and biological impact because you're using metabolites instead of a synthetic material, which would need to be treated in the water waste in a different way. So it has a double impact here. Very interesting and exciting prospect, this technology, and something that really illustrates that this kind of change can actually take place if the product is properly designed and focused. Now, if we move to coatings, which is a huge industry when it comes to general terms, but of course for leather, it means the finishing of the leather is usually a type of coating. They also can be sourced, and this is happening more and more, from natural resources, renewable resources, which are not taken from the geosphere. So these are renewable carbon sources. It can be from crops that produce oil, which can be extracted into vegetable oils, for example, and made into monomers and then polymers, which can be used in your coating. Or it can come from sugar. Carbohydrate containing sugars can be used for this particular process. And again, this is the biotech process that we saw earlier. And you can make, for example, polyurethanes, which are very commonly used in leather for finishing. This is a photo of a water-based polyurethane, so it's polyurethane dispersion that was made with a renewable carbon segment. And if you think of a polyurethane as very loosely and generally as a spaghetti-like mixture of polymer chains suspended in water, then part of that polymer chain, which is polyurethane chain, can actually be replaced by a bio-based polyol segment. And that is already commercial, that's already possible and can be done. So you can make polyurethane finishes using bio-based raw materials. Very interesting. It's something that was introduced into the market a few years ago and has slowly but steadily picked up. And we're at the stage now where these things are commercially being used in some applications already. So that was just a couple of examples of how biotech has influenced leather chemical development. But I would say in general that decarbonisation of the leather and chemical industry in general is already happening. The move away from using depleting resources is underway already. This is something that's not going to stop. The momentum is already there, and we're very much part of that in the leather chemicals industry. Indeed, many leather chemicals can already be made using renewable carbon sources, for example, bio-based raw materials, fermentation of natural ingredients, as we saw in the case of the probiotics and indeed in the polyurethanes. So that's already happening. It can already be done. And there's a significant amount of research going into this, especially for other options of renewable carbon, like using recycled plastics in chemicals, which we're looking at, or even the capture of carbon dioxide from other processes that produce a lot of it, like cement manufacture, for example. That can be redirected and collected and possibly used even in the tanning process. So that's something that's already possible and indeed being worked on, if not yet commercial, I would say. The biomass, bio-based raw materials, those are already commercial and that's already happening. The rest is a little bit more futuristic. And of course, we shouldn't forget that the renewable energy sector is already well developed, as we saw. So the energy that a tannery can use to process these chemicals can also now be sourced from renewable sources, which also adds to the decarbonisation momentum that's happening in the industry. And more to that, if we take a what-if scenario, and I'm thinking a little bit into the future here, but maybe not so far into the future, where we have a tannery that could potentially be at a stage where its decarbonisation has already been done in the tannery and the process is already well underway to a large extent. What would that look like? And this is just a proposal that we could think about for the future, which is quite exciting, I think, and interesting. But first of all, the raw hides could come fresh from the meat industry. Of course, the raw hides are a byproduct of the meat industry. It's a recycled product in some ways. But if they could be received fresh, then of course you avoid the energy associated with freezing or preserving those raw hides. So that's step one. But then what about if the beam house chemicals used were based on natural products, probiotics, enzymes, that's an example, that are made from fermentation. There may be others. But let's say that the beam house cleaning products could be coming from the natural world. Then what if we could use captured carbon dioxide, as we discussed before, from, for example, the cement manufacturing industry? If you could capture the carbon dioxide, use that in the tanning process to improve your process and to make it less carbonized. Then maybe you could use biomass extracts or tannins or other additives in the tanning process to contribute to the decarbonization. Natural oils and additives are already available in many cases for tanning and retanning. Could they be used in larger quantities? Could they substitute synthetic materials? I think there's still a lot of work to be done here. Maybe they could, but certainly the technology exists to make leathers using them. And then finally, bio-based polyurethanes, as we saw. We can already make a bio-based polyurethane at 40–50% bio content, which is quite a significant step compared to a few years ago. So the development in that area is moving towards more and more bio-based content. And then the energy that you use to input into this leather process could be renewable energy from the network, which in many regions of the world is already available. You can buy green energy and it's not much more expensive. And that is a huge saving on carbon dioxide emissions. And that's reportable and you can get certificates for that. But even better, maybe you could even generate the energy yourself from solar panels or wind or biomass. I was at a tannery recently in Spain and they had a whole row of solar panels outside and they were using the energy from those to support much of the electricity needs of their factory. So that's already happening in many industries. And indeed, we in Stahl have our own solar panels in some factories also. So that would be maybe an ideal picture of how the industry could decarbonize. But we're not that far away from this. Many of these things already exist. It's just maybe they're not all put together at the same time. There's a lot of research to be done still on using renewable carbon resources in chemicals in particular. And that is where we're spending a lot of time. But I think potentially we do have a possibility in the not too far away future of having a leather process that's really highly intense in terms of its renewable carbon usage, moving away from the fossil fuel dependence of the past. So thank you very much for your attention. I think all of this is possible. If we can imagine it, we can create it. That's our motto. And I think it's a very good one for this particular topic. So thanks for your attention. Goodbye.
Thank you, Mike. That was very interesting and has given our listeners a really good overview of the latest developments in this sector. I will now hand over to our next presenter, Tom Zong, Henan Prosper Group.
Hello, everybody. I'm Tom. I'm happy to speak to everybody. Today, my topic is new generation biochemical for leather industry. First, contents. First, what is Henan Prosper Group? Second, why we are using these new generation biochemicals? 3, what's the benefits for using these chemicals? 4, future plans. First, what is HP Group? HP Group is founded in 1995. 2004, we moved to new plant. 2008, Colombo mine acquired. 2013, DIP shoe factory is rebuilt. 2014, began using the new biochemicals. 2015, New water treatment plant established. 2016, HP new beam house put into operation. 2017, Cat Tannery launched. We finished design and started civil work. 2018, Mengzhou Rich Industrial Zone launched. 2020, Cat Tannery production begins. For Henan Prosper Group, we have two tanneries. One tannery is Henan Prosper Tannery. For Henan Pro Tannery, we have 3,700 employees. The production is 20 million won lambskin per year. The main production is for duffets for shoes, the minimum and high quality duffets for garment and home care. Home care includes rugs, baby care, paint roller, medical. This means we have a full range of the washing the finished product. Other tannery we call the Kerman Muda. Kerman tannery we have 2,000 employees and the production is 78 million pieces skin per year. Same like Henan Prosper, but Kerman is full focus on Napa. We have the full range of the leather, finished leather production. We have the leather goods, shoes, and garments. What is the new generation chemicals? Biochemical, this new, why we say is new generation of biochemicals. This chemical, the chemistry is come from probiotics. It's completely new technology. It's renewable resource is 100% biodegradable. Even you can drink these chemicals. What is the benefit if we use them for leather process? This new generation of biochemicals is no charge, is compatible with any chemicals. Also, they have a full range pH. This means we can use it with all the process in beam house, from soaking to tanning. Also for duffets, before crust, we have the crust process. Before crust, we have the fabricator with different process with the Napa process. For this chemical, why we use it? We have the two key point process. One, this chemical have the highly power disperse effect for nitrified. This means the big help for the following process for degradation. It have very good degradation effect and also can reduce the quantity of the degradation agent. This big help for the tanning. It's good for tanning, can get a uniform tanning and a uniform color, and also the tight fiber. Also, other key process is we using for the phylic. For phylic, it's big help for the fight absorption. It can increase about 20%. Also, they have the big advantage. It can reduce the temperature of the phylic. It can reduce the 10 degrees centigrade. This means we can save a lot of energy and we can call with low carbon process, not only the eco-friendly energy. Also, you can see this just a green and clean process for the one sheepskin. Also, this can reduce the COD by 12 to 25%. Also for BOD and COD, also increase the proportion of BOD. This means also for the water treatment, we can save of the chemicals. For this chemical, I think we are the first one using this chemical for leather industry, not one of the first. We are very successful and very happy with this chemical for our own sheepskin. For the future plan, for next step, we would like to extend this program to our coming pet project. Also for our Inter Mongolia lambskin. For Inter Mongolia lambskin, now we work for a lot of large brands in Europe. This material has very good quality and is very good for high quality leather goods. For the hide project, we are targeting to produce the high quality. The hide can meet the standard for the big brand, can meet the European market standard. Not only looking for the high quality the leather, also for the process, we are always make our effort to try get the eco-friendly process and the green process, looking for the sustainability and consider quality. We can see for the future, for the leather industry is a normal position of the industry. This means normally we have the big is bad opinion and the leather industry is polluted industry. We can see in the future the leather industry will be green process and eco-friendly. Many thanks.
Okay, thank you very much, Tom. You can post a question to any of the presenters using the GoToWebinar control panel on your screen. Those that are not covered today will be forwarded to our speakers to respond to you. Please make sure you add the name of the presenter your question is addressed to. So Michael, let me begin by asking you a few follow-up questions we received. You mentioned in your presentation that currently bio-based from biomass is more expensive to process into the raw materials for leather chemicals than those from crude oil. In what time frame could we see this scenario reverse?
Yeah, that's a very good question, because like any new technology that comes into any industry, the switch depends on the economies of scale. So the reason that it's more expensive is because it's not being done so much yet relative to the other alternative, the traditional alternative, in this case, petroleum, fossil fuel extraction or mining. So once that switch away from petroleum happens, and more biomass is being processed and more biotech companies are doing it in higher volumes, then the cost will come down. The good news is that in the energy industry, this is already happening. We already see that the prices of the products that we've been sourced in the last 5 years are slowly improving of these biomass materials. But it is quite slow. However, with all the talk and the urgency around climate change, I do expect this to accelerate, in other words, to improve in the next 5 to 10 years. It doesn't mean that I can say here today that in 10 years, the prices of these natural-based products will be the same as the oil, petroleum-based products, because it does depend on demand and supply. But certainly the situation will be significantly better than it is now. So I'm sorry I can't give a definite timeline. All I'll say is that the rate of improvement in the cost of these products will accelerate. It's not a straight line now. I expect it to be more exponential as the political pressures around this climate change topic increase.
Okay, great. And what major advantages do bio-based leather chemicals have versus traditional non-bio-based chemicals in the liquid and solid wastes created by leather manufacture?
Yeah, it depends, because in the beam house process, which is the first main step in the leather manufacturing process, it's where the rawhide is cleaned and you're removing things that you don't want from the rawhide, and those are washed away with water. So the chemicals used in those processes are different than the ones used later, in the sense that they're cleaning and getting things out rather than penetrating and staying in the leather. So in that case, using a natural ingredient like probiotics or even enzymes that were manufactured from fermentation, these are very effective. But they also have shown reduced impact on the water waste in terms of the chemical and biological oxygen depletion, which is a way of measuring the pollution of the water that goes out of your system. Not only are they coming from a natural resource and helping climate change during the manufacture of the chemical, they're also reducing the pollution of the water that you're sending to the water treatment facilities, which can be cost saving, and also obviously it helps reduce the impact on water treatment. So in that case, it really can improve the water waste of your leather process. However, if you use a bio-based polyurethane in finishing, which is the other example I gave, then that really doesn't have any impact on your waste, because you're still applying a product that looks and behaves the same way to your leather. Now, the waste impact of the finishing process is much less than the waste impact of your beam house process. Most of the water, I think 70% of the water waste in the leather process is coming from beam house, and less than 10% comes from the finishing step. But anyway, the point I'm making is that whether a polyurethane is bio-based or petroleum-based, it has no impact on the waste of your leather process. The only impact it has is on climate change, because of the raw materials that you've used to make those polyurethanes.
Thank you. That's clear. Do you think it will be possible in the future to make leather from completely bio-based raw materials, which would also allow leather to become readily biodegradable into compost?
Yeah, this last point you've made is very important to clarify, because using bio-based raw materials is not related to whether the final leather will be compostable or biodegradable. Those are two separate things. Using a bio-based raw material has an impact on climate change during the manufacture of that chemical, but it does not contribute to an improvement in the biodegradability or compostability of the leather, because the biodegradability and compostability of the leather depends on whether the leather can be broken up and disintegrated and dissolved or brought back into nature at the end of its life. And chemicals like these are designed to make the leather last a long time. So even if the chemical is bio-based, it's still designed to make the leather last a long time. And that's one of the important features of leather that we're all trying to improve always, is to make it last a long time, because that's what people recognize as one of the great qualities of leather. But to make leather last a long time, you need to make it very stable and very resistant. So that is a conflict with the idea of biodegradability and compostability. There's a lot of research going on here. It would be great if we had a magic ingredient that we could throw onto the leather at the end of its life and make it biodegrade and compost. But right now that doesn't exist. And for now we have a situation where we want to make leather last a long time, but that also means that it would be less biodegradable. Now, we're talking in relative terms. It doesn't mean that the biodegradability of leather is worse than plastics or other very stable materials. Of course, it's much better because it's a natural material. But relative to not coating, for example, or not putting certain types of chemicals in the leather, that's where the biodegradability, compostability issue is made. What kind of chemicals you add and how much finish you put on to the final leather.
Okay, great, thank you. And finally, which areas of the leather making process, when we consider beam house, wet end and finishing, will be the most challenging in terms of replacing current chemistries with bio-based alternatives?
I think beam house and finishing is probably the most likely areas where we can do this. And the more difficult ones would be in the tanning and retanning part of the wet end process, simply because there are vegetable tanning products already being used for many, many years as the oldest form of tanning. And these are coming from the natural world. They're coming from extracts from biomass. But they produce a certain type of leather, which is very good for certain applications, but doesn't work for many other applications. And that's one of the reasons that chrome tanning was so successful when it was introduced, is because it was able to produce a much wider variety of leather, flexible, all sorts of other properties that vegetable tanned leather could not provide. So for me, that's the more difficult part of the process for the future. If we are to use natural oils in tanning, then so far there isn't a way to do it in such a way that produces the kind of leather that consumers want.
Right. Thank you very much, Mike. That was once again really insightful and has provided a little bit more clarity on this very complex and very fascinating topic. Thank you.
My pleasure. Thank you.
Now, Tom, over to you. We have a few more questions for you also. So the first question, by switching to more bio-based chemicals in the beam house, have you managed to reduce the amount of lime and sulfides that you would normally use? And if so, how much in volume or percentage terms do you think you have reduced your usage by?
We not use the lime in our process. It does not come from Europe. Yeah. For the sulfate, compared with the traditional process, we can reduce about 20%.
Okay, thank you for quantifying this. So quite a bit then, 20%. And when operators in the tannery are handling and adding bio-based products to the process, do any special extra safety precautions need to be considered compared with standard beam house and wet end operations?
This chemical no need. Yeah, this is more safety than traditional chemicals. That you see, I said before, this chemical even you can drink. Very safety chemicals.
Right. Thank you. Yeah, that's really interesting to learn. So they are safer. And a question regarding the finished leather side. On any finished leather using bio-based chemicals, are the physical properties such as feel, smell, and strength, such as tensile or tear test results, the same as leathers made with non-bio-based chemicals?
For the feeling and the smell, it's no different with the traditional process. but for the tensile and tear strength, it can be improved around the 10%. This chemical has a very good in a nitrified display effect. This means can help have the uniform tonnage. The uniform tonnage also increase the performance.
Okay, so there's actually an improvement. That's interesting. And finally, what in your opinion are the main environmental benefits of using bio-based chemicals to make leather?
In this first, they have the very good the display effect for nitrified. This means you can reduce the quantity of degradation agent. Also, this chemical is the base is probiotic. This is very good for environment. It also can reduce the quantity of the COD. Also, this chemical is 100% biodegradable chemicals.
Okay, great. Thank you, Tom, for giving us this overview of how your company uses bio-based chemicals and also what the future holds. Thank you very much.
Thank you.
I would like to conclude the webinar today by thanking our two presenters for sharing their knowledge and insights on this fascinating and increasingly relevant topic. I would also like to thank Stahl once again for the sponsorship. We will be posting the full webinar online shortly in case there were any aspects you would like to listen to again. A link to the recording will be also sent out to everyone who registered for today's presentation. Finally, you will now be asked a short survey about today's webinar to provide feedback, which will help ensure we are offering content that is of genuine interest to you. ILM and the SAUR report will be hosting more free-to-attend webinars over the coming months, so please keep an eye out for future topics on the ILM website. Our contact details can be seen on the screen in front of you now. Thank you for listening. Goodbye.